So if we look at the kind of devices that the Wi-Fi Alliance are certifying today, we see that most of the devices being certified off of the Wi-Fi Alliance are essentially 802.11n standard. These are obviously going out in both the 2.4 and the 5 gigahertz frequencies, and those are the main or the most dominant type of device that is being deployed today in the field. What we're starting to see is a number of devices that are dual band capable and can support one band or the other. We also have a large number of legacy devices both in the 2.4 and in the 5 gigahertz spectrum. So Wi-Fi today is important for a number of reasons to network service providers. The first reason, if we start looking at the types of devices that are coming into the market, we're starting to see a huge growth in smartphones, tablets, portable devices that are starting to become an everyday part of people's lives and need connectivity both within the home and outside of the home. That brings a couple of interesting challenges to network service providers. The first, for connectivity within the home, making it simple, allowing them to set up. And secondly, when you're outside the home, providing an alternate means of getting onto the internet. In addition to smartphones and tablets, the internet is really becoming, to coin a phrase, an Internet of Things. By that, we're starting to see an increasing number of devices connect to the home, domestic appliances, home security devices, cameras, monitoring devices, all looking to connect either via a wireless protocol or via one of the emerging Wi-Fi standards. And then the last thing that we're starting to see, specifically in the network service provider arena, is the use of Wi-Fi to simplify and ease the installation of video set-top boxes around the home. From a video over IP type perspective, we're starting to use or see increasing use of Wi-Fi as a means of installing set-top boxes where customers want without the need for wires. So if we're looking at how the market evolves in the next 12 to 18 months, we're looking at three broad areas. The first area, which is important to the market, is the introduction of 802.11ac. We're starting to see products based on this standard coming to market prior to the certification capability by the Wi-Fi Alliance. The second trend that we're seeing is the standardization or the Wi-Fi Alliance's Passpoint program, which essentially allows for simplification of connectivity of devices to hotspots and authentication of those devices. And then the third important trend, specifically for NSPs, is the increasing troubleshooting tools, capabilities, and the pieces of the puzzle that really help a network service provider provide a good support mechanism or support service to their customers. So there's been a lot of hype and a lot of talk about the 802.11ac standard, and how does that compare, or what does it offer in terms of advantages over the 11n standard we're seeing today? And the first thing to remember about 11ac is that essentially it is backward compatible with the 11n standard. So you can deploy 11ac devices into the home network without the worry of them interfering or not coexisting with any 11n devices you have in that 5 gigahertz spectrum. If you look at the throughput capability of 11ac, we've seen a lot of marketing around the different throughputs that are achievable, mostly around the theoretical radio rates, but what we're starting to see is through wider channels and through increased QAM modulation schemes, a much better throughput per radio. Then you start adding the number of radios and channels that you can support. 802.11ac standardizes the capability up to 8x8 configurations. We've seen on the market today an increase in 3x3, and we're starting to see 4x4 options come to the marketplace. So extending this to 8x8 is more than enough from a throughput perspective for the foreseeable future. Beamforming in 11ac is standardized, so if you implement beamforming in your client and in your access point, you have to do it in a specific standardized degree way. Up until now, the 11n standard has allowed for proprietary solutions. 11ac standardizes this mechanism to start to permit or push for interoperability between different vendors, clients, and access points. And then the last main advantage of 11ac is the support for multi-user MIMO, a technology that's come from the mobile world. All of these features and functions are being put together in latest generation silicon, with the addition typically of an offload processor that starts to reduce the burden on the host processor. So what does all this mean or translate to the end user? Well, importantly, this new standard is backward compatible. We're providing more throughput per radio, so we're starting to see that a fixed amount of data will get transferred quicker, so we start to see radio active times compared to their quiet times be lower, and we start to see battery life improvements in portable and mobile devices. We're starting to see an increase in coverage within the home through beamforming, and we start to see an increasing speed for the additional capabilities on those radios. So the main benefits of 11AC can really be distilled down to four main areas. The first one is because it is standards and interoperates with the 11N standard that already exists in the 5 GHz spectrum, it is backwards compatible. You're not going to see the same concern in introducing 11AC into your network as you did with the previous draft, pre-N and different versions of 11N standard. The second main reason is essentially that, as we talked about earlier, you're going to get more throughput per wireless radio device. So what does that mean? If a user's got a low-end portable tablet or smartphone device, to transfer a given amount of data to that device, it's going to take less time. The radio is active for a lower period of time and uses less power as a consequence. Alternatively, we're starting to see an increase in radio throughput to that device, so maybe new services can be enabled on smartphone and portable devices without them having to go to a more complex radio configuration. The support for additional channel bonding and the support for wider channels, that additional throughput starts to give you higher speed capabilities. We're seeing 3x3 commonly touted as a means to get to gigabit Ethernet speeds. And then lastly, the standardization of beamforming and combining that with multi-user MIMO technologies can start to see improvement with the coverage within the home. So if we look to the key silicon providers and the technology providers that are supporting 11AC, all of them have announced roadmaps and products around the 11AC standard. Already we're seeing the first silicon in the marketplace and the first devices based on that silicon delivering primarily into the retail space. So the quick and easy answer is yes, I can go and buy 11AC devices today in the retail space. Now, I think one important factor, though, to consider is the Wi-Fi Alliance and their certification process, and we don't really expect to see that to start to get underway until the first quarter of next year, or the first quarter of 2013. And so from that perspective, when we're talking to network service providers, we feel that the Wi-Fi certification is really needed just to provide that underlying proof that a device is certified and should interoperate with any kind of access point that's being deployed. So at a high level perspective, when we're looking at the roadmap we have here at Technicolor, we're looking at trying to make sure our products can bring that 11AC capability to the market space beyond that Wi-Fi Alliance certification. So if an operator is looking to deploy or refresh their lineup in the second half of 2013, we would highly recommend that they look closely at an 11AC option in the 5 GHz space. So as we mentioned earlier, there's a large growth in smartphones and tablet devices that essentially is fueling connectivity within the home and fueling the demand for bandwidth. This presents a couple of challenges. So within the home, how do these devices simply connect and offload their data and traffic into the home network or into the fixed network instead of the cellular network? And secondly, I think we're all familiar with that problem when you're at the airport, perhaps in a country you don't know, and you're trying to find internet access on that device. You'll get presented with a list of hotspot services that are available. You then have to select one. You then have to find one that's a roaming partner of whoever you have a contract or service with. You authenticate. The process itself is long and cumbersome. HOTSPOT 2.0, or the Passpoint program as it's become called by the Wi-Fi Alliance, is essentially the simplification through standardization of the discovery and connectivity of a device to a hotspot, to a public hotspot service. This has additional benefits within the home, and it can be used for that, simplifying that first time connect within the home to an access point or a gateway that supports the process too. So if we look today at the typical connectivity scenario, so I take my cell phone or I take my laptop, I'm trying to connect to a public hotspot. The first thing I don't know is A, whether I'm entitled to connect, B, how much is it going to cost me, does my cellular provider or my home network provider have a roaming agreement, can I even remember my username and password, and such challenges in terms of getting connectivity. The process itself is difficult, cumbersome, and requires interactivity on the user interface. If we start looking at what the Passpoint program brings to this, it brings a mechanism for discovering local hotspots. It brings a mechanism for querying the access point that's providing that hotspot and looking at its capacity, its capability, the number of devices that are connecting. And essentially allows that interface to be brought back to either allow a device to automatically connect to a preferred partner or a preferred speed. But in time, it would also allow that information to be presented back for the user to make an educated choice on which hotspot he wants to connect to. So the benefits of Passpoint fall into a number of different categories. The first one is the benefit to the user or the end user, in that it can simplify the process of me connecting to hotspots or access points irrespective of where I'm located. Now that could be that I'm doing that at home and I'm trying to connect to my own private access point, and it simplifies the process of connecting a device for the first time to my home network. And that can have obvious benefits to the network service provider as well in terms of lower support and troubleshooting calls. From a second perspective, it could be that I'm out in a public place and I can now seamlessly connect to a public hotspot. I can authenticate myself to that hotspot. I simplify any billing or any transactions that go on the back end. It allows it to happen transparently to me as well. The third benefit is essentially due to me trying to connect perhaps as a guest or to a guest hotspot at a friend or a family. I can start looking at ways of simplifying my capability to connect to my parents or my mother-in-law's home network when I visit, and I can start looking at tying that into services that enable transparent sharing of content or sharing of photos while I'm on that guest hotspot. All of these are going to start translating or coming together to support a range of new business models, a range of business models where network service providers can provide offload services to cellular providers, can provide new services around content sharing and content hosting or backup, or can provide a new range of metropolitan Wi-Fi type services that we're starting to see become popular in certain regions. The main features of Passpoint can be listed as follows. Firstly, network discovery and selection of the network based on a number of different criteria, making the connectivity problem simpler for the end user. Second, that can lead to seamless network access where the whole transaction is transparent to the end user. He doesn't have to interact with a user interface or a browser on his device. Passpoint also brings into play new enhanced security features, the support for WPA2 Enterprise as a minimum and EAP to provide a more secure connection environment. We start to see addition for operator policies, allowing operators to provide direction and selection on which partners or which roaming agreements they have in place, and start to allow them to cross-authenticate themselves on the back end. And essentially Passpoint, by virtue of being a collaboration between the Wi-Fi Alliance and the Wireless Broadband Alliance, has met both the requirements for the end users, consumer electronics devices, as well as meeting operational requirements for the broadband access providers. So a last benefit for Passpoint is that these things together can start to see the residential gateway provide a mechanism for service providers to leverage any spare bandwidth they might have on that backhaul connection to either be sold or to provide connectivity to the services to both the end user within his own home, but also to other users in the proximity of his home, and might start to see a more prevalent deployment of community Wi-Fi programs such as we've seen with FON and certain other operators in the field today. So as with any new feature and function, particularly in the wireless world, There are always challenges in making sure that help desks can support these features and can provide continual support to end customers. So there are two things that can be done here. So the first thing is that as these new standards are evolving, we're also starting to see more care and consideration taken to the challenge of supporting Wi-Fi services within the home and intrinsically building some of those features and functions into the standards that make that support simpler for network service providers. In terms of that, we're starting to see an emerging number of tools that can help support these services and features as they get deployed by network service providers. And at Technicolor, we like to try and make sure that we're at the forefront of providing tools that help network service providers troubleshoot their connectivity within their home, both wireless and wired connectivity. There are a number of different sources or causes for Wi-Fi issues. They can broadly be put into three categories. The first one relates to auto channel selection, and essentially is the capability or the ability of an access point or a gateway to select the appropriate Wi-Fi channel in the first place. At Technicolor, we've put a number of enhancements into our auto channel selection process so that our gateway can intelligently choose the right wireless network and can monitor that network and make the appropriate changes as and when required. The second category is associated with connectivity issues and is how do you get a device connected to the network in the first place. As we spoke earlier, there's a little bit of enhancement in the pipeline with the Passpoint program. But in addition to that, providing troubleshooting tools that can really dig deep into the Wi-Fi stack on our gateway, provide connectivity history, provide triggered logging, provide an event capability that can store or look at the history, look at the relative signal strength, can allow you to start bringing information up to a troubleshooting tool. The last issue essentially is related to performance and users or end users not getting the coverage or the throughput they want within their home. And this relates to a number of different underlying decisions that are made in the design of a gateway. At Technicolor, we always like to make sure that we've chosen best in breed from a wireless performance, so we make sure that we've benchmarked the different technologies. We look at doing or driving or controlling our hardware design to make sure that the radios are optimally positioned within the device, free and clear of other interferers on the radio channels themselves. Thirdly, we want to make sure that our device is architected with sufficient performance to make sure you can support the speeds or feeds that you want to provide to the end user. And then we have a whole range of different devices right through from 1x1 configurations through to 4x4 at the top end to make sure we provide a coverage that's far in excess of requirements and can even support a full high quality video to multiple devices and multiple set-top boxes within the home for video distribution. So the last 10-15 minutes, we've just touched on a number of the different aspects and a number of different evolutions we're seeing come to the market in the next 12 to 18 months. We've talked about some of the design issues, some of the challenges that we've tried to overcome here at Technicolor. More information on everything that we've been discussing today can be found on our website and in our white papers on our website, and the address is on the screen below.